Okay, the first thing we'll look at today, once again, is your bell work from yesterday or from this morning. The bell work that you had was working with parallel and perpendicular lines and just determining whether they were truly parallel, perpendicular, or neither. Okay, so this first one here, first thing, slopes of parallel lines. Hopefully we remember we would have been filling in the word same here. Slopes of parallel line are the same. Next one, slopes of perpendicular lines. We had two words, opposite, which means opposite signs, so like one positive, one negative, and then reciprocals. And reciprocals refer to fractions that are flipped over. So if we were to give examples here, like 2/3 and a -3/2, or a -2 and a positive 1/2. Those would all be examples of opposite reciprocals. Okay, so for number one here, determining whether the lines are parallel, perpendicular, or neither, you should have said that the slope of the first one is a -2, slope of the second one is a +4. So they don't fit either one of the top two categories. So we would have been circling the word neither here. On this next one, the slope of the first one is 6/5. The slope of the second one is 6/5. Since those two lines have the same slope, we would say those two lines are parallel. Okay, for the next one. Next one, here's what we've got. We've got a +4/3. We got a -3/4. They aren't the same, so they're not parallel. They have opposite signs, and they are flipped over, so those two would be the ones that we would consider perpendicular. Okay, slope of the next one. The slope of the next one, we should add a -5/2, and the slope of the bottom one would be a +2/5. So again, they're not the same slopes, so they're not parallel. They are opposite signs, and they are reciprocals, so they would be perpendicular. Okay, and for the last one, we got a +6 for a slope on the top one, and it's 4 minus 6x. So on the bottom, we would say the slope is a -6. So they're not the same slope. They are opposite signs, but they're not reciprocals, so they're not perpendicular. So we would have said that those two lines were neither parallel nor perpendicular. Okay, so the next thing that you should have on your desk is the, I would call it a gold sheet. That gold sheet, it says notes for writing equations of parallel and perpendicular lines. And that's what we're going to walk through together today. So please follow along. So first of all, writing equations for parallel or perpendicular lines. Here's the type of problem that you're going to see. First of all, let's just remember slopes of parallel lines are the same. Perpendicular lines are lines that intersect at a 90-degree angle, and those slopes of perpendicular lines are opposite reciprocals. So those are, again, big concepts written right at the top of your note sheet. It was written at the top of your bell worksheet today, so big concepts. Here's the type of problem that you're going to see. So we'll say something like this. What is the equation of a line or of the line that passes through the point 3, -1 and is parallel to y equals -4x plus 1? Give your answer in slope-intercept form. So a lot of information in that one question. So first thing, we look at the line that we're given, which is this y equals -4x plus 1. From that line, we can tell the slope, and the slope of that line is a -4. The question asks to find a parallel line. So when I say slope of a new line, we're thinking about if the slope of the old line is -4 and those two lines are parallel, they'd have to have the same slope since they're parallel. So we knew the slope of this new line would also have to be a -4. From there, we can write an equation in point-slope form. Given this point and this slope, if you remember, point-slope form is y minus y1 equals m times x minus x1. So these three things get replaced. So if I'm going to write it in point slope form, that form would be y minus the y value in this case is negative 1 equals m, which we found was a negative 4. And then it would be an x minus a x value, which in this case is a 3. So if I just start simplifying this now, because we want to rewrite it in slope-intercept form, some things that I do on this side over here, I would rewrite that as y plus a 1, and I would distribute on the other side, and that would be a negative 4x plus a 12. Okay, and we've done this enough now. Hopefully we can see that. I would then minus the 1 from both sides, and I'd get y equals negative 4x plus 11. And then I would move my negative 4x to the other side, so I'd add 4x, and I would get 4x plus a y equals an 11. Oh my gosh, and I didn't need to go to standard form, so I went too far. Stop right here. I apologize. We do not need to go to this step. We are just getting into slope-intercept form. Okay, we will take a look at the next one. Next one's a similar problem. This time we want to go parallel lines. Again, so if I read through that problem, it says, what is the equation of the line that passes through 2, 4 and is parallel to y equals 3x plus 1? Give your answer in slope-intercept form. Okay, so again, parallel lines, so we're thinking same slope. We know the slope of this line, which would be our old slope, would be a 3. Slope of the new line, well, if they're parallel, they'd have to have the same slope. So our slope of our new line is 3. We know that it goes through this point, 2, 4. I got a slope of 3. So we're thinking putting those into this form now. Point slope form, which is y minus y1 equals m times x minus x1. Again, we're going to fill in the things we know. We know the y value, we know an m, we know an x value. So if I start filling those in for point slope form, it would be y minus the y value, which hopefully we can see from the equation here, or excuse me, from the point is a 2. No, it's not. I lied again. I apologize. Y value is a 4, so it's y minus a 4 equals a 3, parentheses, x minus the x value of a 2. Okay, from there, I'm going to rewrite it in the slope-intercept form. So I would need to distribute the 3, and I'd get 3x minus a 6. On this side, I got a y minus a 4. To get that into slope-intercept form, the last thing I'd have to do is just add a 4. So my equation would be y equals 3x minus a 2. There would be my answer in slope-intercept form. Okay, the next one. Next one we're going to look at a very similar problem, except now, let's read it. It says, what is the equation line that passes through the point 6, negative 4, and is perpendicular to y equals 1/2 x minus 4? Give your answer in slope-intercept form. So the only difference here now is the word perpendicular. And for perpendicular, you should be thinking in our head, those slopes are opposite reciprocals. Okay, so for this one, our old slope, if we look at this equation right here, we should be able to see that our slope is 1/2. If we thought about what's the slope of the new line, we're thinking about perpendicular lines. Perpendicular lines, opposite reciprocals. So we know it's going to have to go from a positive to a negative. And we're going to flip 1/2 over, which should be a 2 or a 2 over a 1. For the ease of it, we're just going to use a negative 2. Okay, so now we're going to write our new equation in point slope form, which is y minus y1 equals m times x minus x1 again. These three things are getting replaced. Here's a piece of the puzzle. So I'd have y minus the y value. The y value in this case is a negative 4. So I'll write it like this. Equals the m, which is a negative 2. And then x minus the x value, which is a 6. Okay, so there would be point slope form. If I wanted to rewrite that into slope-intercept form, I would first rewrite this side over here to y plus a 4. I would distribute the negative 2, and I'd get a negative 2x plus a 12. I would then minus the 4, and I would get y equals a negative 2x plus an 8. So there would be your equation for that one in slope-intercept form. Okay, I'm going to let you get started on this one by yourself, and let's see how far you can get. And again, I want you to pause the video. Okay, so again, we got perpendiculars, so we should be thinking opposite reciprocals. Okay, opposite reciprocals. So the slope of my old line. So the old slope would be this. It would be a negative 3 over 2. Hopefully from that we can tell our new slope, which would be a positive, and we'd flip it, so it would be a positive 2/3. If I want to write that in point slope form, again, point slope form is this. So I'm going to replace these three things, and we should have gotten this. Y minus a 4 equals a 2/3 x minus a 12. And then if I go to rewrite that into slope-intercept form, I would distribute the 2/3. So I'm going to have y minus a 4 equals 2/3 x. And if I distribute 2/3 times the negative 12, or the 12 to start with, it's like 12 over 1. So that would be 24 over 3, which is 8. So this would be minus an 8. From there, I would add 4. And you should get y equals 2/3 x minus a 4. Okay, so for today, you've got the green assignment. There are 6 problems that you have to do on your own like this. I believe 3 of them are for parallel lines, and 3 of them are for perpendicular lines. And please use these examples that we went through in class to help you out. Okay, and we'll see you on Tuesday.